Disclaimer. This lesson is not designed for use as medical references to diagnose, treat, or prevent medical illnesses or trauma. If you have questions about the diagnosis, treatment, or prevention of a medical condition or illness, please consult your personal physician.
The wide-ranging field of medical geology covers both health problems caused by naturally occurring earth materials and the health benefits of geologic materials. Geologic materials have been mentioned as possessing properties that were both beneficial to health and poisonous since ancient times. Medical geology has been studied on a case-by-case basis since writing about medicine began. Now, because of global concerns about the health impacts of naturally occurring and human-manufactured materials, the subject has received renewed interest. In 2016, the National Institutes of Health borrowed over 40 minerals from the Smithsonian Institute to set up a display of minerals in medicine at their clinical center outside of Bethesda, Maryland. For example, azurite is a source of copper. Copper is an important trace element in terms of health, but too much or too little can cause serious damage. Outside the body, copper is a potent antimicrobial agent used in everything from bed rails to topical antiseptics. Colemanite, found in Death Valley, is a source of boron, an element in borax, and boric acid. Boric acid has antiseptic and antifungal properties. Boron may be useful in the treatment of arthritis and multiple myeloma. But the beneficial health effects of geology have been known for centuries. In ancient Chinese texts, 46 minerals are described as having beneficial medicinal properties. These include minerals with arsenic sulfide. Of course, over-application of these arsenic minerals is toxic. But that's not just true for arsenic. Paracelsus, the 15th century founder of modern toxicology, famously wrote, "All things are poison, only the dose makes the thing not a poison." In short, the dose makes the poison. With his view that small doses need not be toxic, he promoted the medicinal use of small amounts of metals, minerals, and inorganic salts. Paracelsus personally recommended the medical use of mercury, lead, and antimony, substances we know now are toxic even at the doses he recommended. On the other hand, copper was used by ancient Egyptians, Greeks, Romans, and Aztecs to treat burns and some infections, and modern hospitals have begun to include copper in surfaces that get a lot of patient contact, such as bed rails, IV poles, and the handles for faucets, toilets, and cabinets. In any case, determining what to prescribe for a particular condition in a particular patient remains something that is best decided with your own doctor. I do not endorse or recommend medical treatments based on any of the geologic materials or products derived from them that I will talk about in this lecture. I'm a geologist, not a doctor. With any and all medicines and treatments, you first should talk to a physician before using them. Whether from ancient times or from the modern approach to medicine begun by Paracelsus, many people have the conviction that the direct use of geologic materials can provide health benefits. Let me give you a couple of examples. Petroleum oil occurs in a variety of locations around the world as oil seeps or tar pits, where naturally occurring petroleum seeps up out of the ground. The La Brea tar pits in Los Angeles are one famous example. But oil seeps have done far more than trap animals. Ancient humans in Mesopotamia and elsewhere used tar to waterproof their buildings and boats. Medicinal applications of tar are known in Persia from before the year 1000. It was used on skin as a balm. Additional uses included the treatment of reptile bites and to treat hysteria. Petroleum still shows up today in medical uses. Petrochemicals provide components of medicinal chemicals. They're used to synthesize aspirin and make up the coating on pills, and to control time-release drugs. More importantly, petrochemicals are used in the manufacture of plastics, such as vials and syringes, and sterilizing agents such as hand sanitizers and bandages. Petrochemicals serve an important role in the prevention of infection. Salt is an important nutrient as well as medical agent. Many animals travel to specific locations to lick specific mineral deposits as a way to get salt, magnesium, calcium, and other minerals in their diet. Native Americans and other hunters became familiar with salt licks and mineral springs as places to hunt buffalo. Native Americans in the eastern part of the United States extracted salt from concentrated locations and then traded their salt for other goods. Where does salt occur? The Avery Island Salt Dome in Louisiana, later famous for contributing to Tabasco sauce, is one of the most prominent salt concentrations in the U.S. Additionally, salt is mined from Paleozoic rocks in Kansas, Michigan, and throughout the Midwest. The antiseptic qualities of salt water were already recognized in the ancient world both for healing and preserving. Although salt, which is a sedimentary rock, was mined throughout Europe, one of the important industries of Venice was the crystallization of salt from seawater. The 19th century author Henry James would write about soaking for hours in salt brines and salt spas of Venice, located near the Santa Maria della Salute. They were thought to cure arthritis, breathing problems, and skin issues. Today, there's renewed interest in salt spas, salt floats, salt rooms, and salt caves. The suggestion is that it's both relaxing and improves breathing. However, since 2000, no larger scale studies or small scale studies involving placebos have documented any health benefits of salt treatments. Amber was used before and during the Middle Ages as a folk medicine for throat and stomach problems. Much to the chagrin of current-day paleontologists, amber was often burned for therapeutic purposes. People would go into a closed room where amber was burned to breathe in the fumes to clear the lungs, or as a general curative. Hours spent in amber smoke was thought to cure a variety of ills. Thinking as a paleontologist, imagine all the fossils lost when the amber was burned. Of course, not all amber contains fossils, but still, there went a lot of geologic history up in smoke. Throughout history, some people have also attributed healing or protective powers to the mere possession of minerals just sitting on your table or worn as jewelry. Amber is one and quartz is another that people say have a positive energy. But there aren't enough studies and statistical data to properly support the claims of their health benefits. I think they are interesting, and it's certainly interesting that people throughout history have sought geologic materials for health. I'm glad people find a benefit from them. Relaxing in a salt spa and reading a Henry James novel sounds beneficial to me. But two things. First, don't spend a lot of money on something that may not help you. Second, you should always consult your doctor when you start a new health regimen. Now let's consider some ways that some local geology can negatively affect health. Before I do, I want to emphasize that the health problems I'll discuss are endemic only in certain areas, and those areas are well known. Outside those areas, there is statistically little chance that you will encounter the health problems I will describe. Don't lose sleep over this. Rather, focus on this amazing planet of ours and how geologists are helping to help people around the world. That said, we can organize these geologic hazards into things that the surface of your body is exposed to, materials that you breathe, materials that you drink, and finally, geologic materials that you eat. The principal concern of people in terms of exposure to geologic hazards is, of course, radiation. There are many naturally occurring radioactive materials. Uranium, thorium, and radioactive potassium together account for half of planet Earth's internal heat. And as they decay, they produce other radioactive elements. Radon is the most commonly encountered source of health problems due to radioactivity. Radon is a naturally occurring radioactive element that's formed by the radioactive decay of uranium. Uranium decays through a multi-step process where the final product is the stable element lead. But along the way, there are intermediate steps, including the production of thorium, then radium, and then radon. Radon occurs as a gas, but it is commonly associated with certain types of rocks. Radon will move through fractures in rocks and soil and work its way into houses through cracks in the basement. If a house is well sealed and or well insulated, ironically, that is when radon gas can collect inside. The buildup of radon in buildings was first recognized accidentally. A radiation monitoring system in a nuclear power plant picked up high levels of radon that were not coming from the plant. That began extensive research into the dangers of household levels of radon in the late 1980s. This is a well-known problem that's been studied for a long time. It turns out that exposure to radon has been quite dangerous. The EPA has estimated that between 5,000 and 20,000 people die of lung cancer each year due to the inhalation of radon and its decay products. That means that radon is the #2 cause of lung cancer beyond smoking in the United States. Geologists are well aware of the problem. The rocks that are high in radon content are older silicic granites, which contain uranium, thorium, and radioactive potassium. Also, organic-rich clays and shales are deposited in reducing environments. In a reducing environment, naturally occurring uranium and clay minerals is immobile, so it builds up over time. Also, phosphates contain uranium and thorium, but even more problematic is waste phosphate. During processing of phosphate fertilizers, uranium and thorium are concentrated in the waste product. Radon is also associated with some carbonates and hydrothermal ore deposits, again because of the presence of uranium. In the U.S., those states that have these types of rocks frequently have had state government mapping projects that identify areas of concern. The Kentucky Geologic Survey, for example, has mapped the entire state on the basis of their radon potential. In Kentucky, the rocks that have the highest uranium contents include organic-rich black shales and limestone rich in phosphate. The color-coded geologic map that was generated indicates the location of rocks that have exceeded the recommended maximum level of 4 picocuries of radiation per liter of air. Households above the recommended level rarely exceed 25 or 30 picocuries per liter, but even 100 picocuries does occur. There was one house in Pennsylvania that had a level of 2,000 picocuries per liter. In the U.S., 32 states have rocks that result in radon exposures above the recommended max level of 4 picocuries. So what can you do if you're concerned about high radon levels? It's always a good idea to test if there is any question. One way you can find out if there's a radon problem is to call or visit the local hardware store. In areas where there's no concern over radon levels, stores don't carry radon testing kits. If your local hardware store sells radon detection kits, there's a stronger chance it's worth testing radon levels in your house. There are 2 types of radon testing kits. One is charcoal, the other is film. You unwrap them, they usually come in a metal foil bag, and then leave them in your house for 2 to 4 weeks. Just follow the directions on the package. After the testing period, you send the element back to the manufacturer. When my first child was born, we put a kit in the basement, one in the playroom, and one in the nursery. The tests all came back negative in our case. If, however, we did get a result that was above 4 picocuries per liter, we would have been advised to do further testing and, if needed, remediation. The pathways for radon are most frequently cracks in the foundation, where radon gas makes its way into a structure. But radon can also enter a house through water systems and any location in the house where you might feel a draft. To remediate a radon problem, all you have to do is generate a pathway for the radon to leave the house. Radon is heavier than air, so it tends to sink into basements and just below the foundation. But the good news is that radon movement is easily influenced by air currents. So a pathway for radon to leave usually comes in the form of additional ventilation. Newer houses in areas where radon problems have been encountered will have a PVC pipe that runs from beneath the foundation, through the foundation, up through all the floors of the house, and then up through the roof. Essentially, any radon collecting beneath the foundation finds a pathway through that PVC pipe directly into the atmosphere. Now, radon has also been cited as a benefit to health. Ever since the time of ancient Greeks, radon levels appear in elevated concentrations in hot springs that are sought out for their healing powers. The term spa is believed to be an acronym, Sanus per Aquam, Latin for health through water. And it's not just the water. The popularity of hot springs has been celebrated through the ages in part because the presence of minerals or other substances in the water has been thought to be beneficial. But the popularity of spas declined after U.S. government studies of hot springs in the 1960s revealed the presence of high levels of radon. But radon spas are still used. What's going on here? A 2015 study looked at the ramifications of human exposure to low levels of radon in hot springs in Europe. They concluded that if exposure occurs over a short term, there do appear to be benefits and a noted absence of fatalities. Waters with radon appear to have analgesic and anti-inflammatory properties. Conditions that have been treated in radioactive spas include rheumatoid arthritis, bronchial asthma, and psoriasis. So there do seem to be some benefits at low doses, but the dangers of overexposure are indeed well documented. Inhaling dry geologic materials is another source of potential harm. Naturally occurring dust and asbestos are two widely cited health hazards. Beyond whatever issues may be posed by dust itself, dust is also a danger because of things that can be transported on the surface of dust particles. The materials used to make roads, for example, such as asphalt or concrete, are constantly wearing away, and on roads with especially heavy vehicles or wherever snow tires are used, the amount of dust released into the atmosphere can be much greater. One particularly odd example of what dust can transport are the outbreaks of valley fever that occur after earthquakes. In arid regions of the U.S. and Mexico, two species of fungal spores called Coccozoides are carried by dust particles. Earthquakes will kick up large amounts of dust over large regions and spread those fungal spores in dust clouds. The 1994 Northridge earthquake is noted because of the numerous outbreaks of valley fever caused by the dust generated by both the earthquake and the landslides the earthquake triggered. The death toll from the quake itself was 57 people, but at least 3 more people died as a result of valley fever triggered by that dust event. There are also minerals when inhaled that cause health problems. The most famous of these is asbestos. Asbestos is a catch-all term for a group of minerals belonging to the serpentine group or the amphibole group, which is a common rock-forming silicate mineral. In that catch-all term are some asbestos minerals that cause more problems and other asbestos minerals that clear from the body more readily. The carcinogenic asbestos minerals, those that cause health problems, characteristically occur in long, fibrous crystal forms. When taken into the lungs, those fibers break apart and are embedded on the lining of the lungs. There's a clear relationship between exposure to respirable carcinogenic asbestos and mesothelioma lung cancer and asbestosis. The World Health Organization has identified 6 asbestos minerals linked to cancer. The most common of these is blue asbestos, also known as crocidolite. Another of the 6 types the WHO has warned against is white asbestos, the mineral chrysotile, which makes up the majority of asbestos used for insulation. The stuff is heat resistant and chemically inert, so initially it was viewed as a wonder product. The crystal form of white asbestos is a sheet structure. It's also important to remember that by and large, asbestos-related health problems result from either the extraction of asbestos minerals or the manufacture of asbestos products or the end-of-life breakdown of asbestos products. It is more rare for naturally occurring asbestos or asbestos-like minerals to cause a problem. According to OSHA, there are other respirable geologic materials that can be harmful. For example, quartz dust has been designated by some international health organizations as a carcinogen. The problem is silicosis, a group of lung diseases usually caused by industrial levels of exposure to quartz dust. But in its haste to protect the public, OSHA declared that all products containing more than 0.1% quartz or free silica will have a warning sign placed on the packaging. So does that mean activities like sanding wood with quartz sandpaper or using sand and gravel to make household concrete are dangerous? How about beaches or gravel roads? Or what about driving behind trucks hauling sand? Are they dangerous? Although silicosis is a serious family of diseases and the causes of individual cases can be difficult to diagnose, minor exposures to quartz shouldn't harm you. Most health officials would tell you that silicosis seems to involve industrial levels of exposure rather than just occasional intake. The next group of geologic health concerns are those chemicals that you drink. These are geologically sourced elements that make their way into your water. Trace elements are an important part of human health. As most people are aware, there are essential trace elements. If individuals are deficient in these elements, they develop health problems. But there are also trace elements that occur naturally that can cause health problems. One of the more troublesome geologically sourced elements is arsenic. Arsenic is even more ubiquitous than fluoride. Dangerous levels of arsenic are frequently the result of human activities, including mining, the production of pesticides and pharmaceuticals, glass production, and the generation of electronics. The reality, though, is that most of the arsenic in drinking water is from natural sources. Mapping by the U.S. Geological Survey in 2005 shows that many states are affected by high levels of arsenic in drinking water wells. The geologic origin of arsenic isn't always easy to identify. That makes the problem so much more insidious. Arsenic has sources in iron oxide minerals, sulfide minerals such as pyrite, and coal has a strong association with arsenic. So arsenic can come from both groundwater and the ash fallout from burning coal. In Bangladesh, India, China, Taiwan, Vietnam, and Mexico, arsenic in drinking water has caused health problems for millions of people. Those problems include cardiovascular diseases, developmental anomalies, neurological disorders, diabetes, multiple cancers, and other health issues. This is a global problem that really hasn't found good answers. So where are we? I've talked about exposure to natural radiation, the respiration of small geologic materials, and the drinking of naturally occurring trace elements. We have one more to do. Oh yeah, that's eating geologic materials. A lot of people say, eating rocks? The answer is yes. Well, almost yes. Geophagia is defined as the deliberate consumption of earth, soil, or clay. Your immediate reaction might be, no way, but you eat calcite when you take Tums for your stomach. Kaolinite, the clay mineral, is the active ingredient in kaopectate, which is an antidiarrheal. The mineral magnesite is the key ingredient in milk of magnesia. People are eating geologic materials every day. Geophagia, however, is the straight up, down the hatch consumption of earth, soil, or clay. Geophagia is a long way from Tums. The Colombian writer Gabriel Garcia Marquez described geophagia in his book 100 Years of Solitude. Rebecca got up in the middle of the night and ate handfuls of earth in the garden with suicidal drive, weeping with pain and fury, chewing tender earthworms and chipping her teeth on snail shells. Geophagia isn't pretty, but it is really interesting. Geophagia is really difficult to explain medically. First of all, the practice of earth eating has existed since the ancient Greeks, and it has been described by doctors and scientists essentially since the first medical texts were written. Part of the problem with understanding geophagia is that it shows up in populations of many different cultures at many different times. So almost certainly there are multiple causes. Various individuals have suggested that geophagia is a psychiatric disorder, a culturally driven phenomena, the result of famine, an attempt to increase the body's minerals and trace elements, and an attempt to aid in the body's ability to ward off disease. What do I mean by the appearance of geophagia in different cultures and at different times? Hippocrates seemed to associate geophagia in ancient Greece with pregnancy. Ancient Romans concluded that clay eaters had lighter skin. In ancient Turkey, the association of clay eating and pregnancy was also reported. Egyptians believed that eating soil would solve stomach problems. With the development of medical sciences and the increase in travel of scientists, observations of geophagia increased markedly in the 17th, 18th, and 19th century. Native Americans used soil to season food. South Americans were observed to eat clay during famine. And in Africa, soil was used to cure diseases such as syphilis and diarrhea. In the American South, the consumption of white clay by slaves was considered a problem by slave owners, and efforts were made to prevent it. But in the 1950s and 1960s, you could buy bags of clay to eat in most grocery stores in the American South. In fact, clay eating by all people of all races still exists today in the American South, though there's a level of differentiation, and which clay is preferred can differ from one state to another. So what in the world gives with geophagia? Geophagia is sometimes classified as a form of pica, but pica is a psychological disorder that involves the compulsive eating of any non-food items. This is different from geophagia. Geophagia only involves eating earth, clay, and soil. It's not always compulsive. There are cultural celebrations that involve the eating of dirt. Specifically, groups that have ceremonies to honor and form a closer tie to an earth mother eat soil. So in the end, there seems to be arguments for several causes of geophagia. First, an attempt to regulate iron seems to be a consistent suggestion throughout medical history. Second, there is a casual correlation of geophagia with episodes of famine and poverty. Third, there are religious ceremonies that seem to tie geophagia with an earth-centered worship. Last is to ward off diseases. A 2008 paper in the journal Nature described chimpanzees eating soil, particularly soil with leaves in it. Analysis indicated that leaves while on the plant had limited medicinal benefits, but once in the soil and decaying there was an increase in the availability of chemicals known to prevent malaria. In this case, geophagia by chimpanzees is attributed to an attempt to build up immunity to malaria. So why geophagia? It's a tough call, but an interesting phenomenon. You know the next part is coming, right? Everything old is new again. People are still eating soil and clay. In recent days, cooking with soil has become a trend. Plenty of recipes that include soil or clay as an ingredient. There are fad diets such as the Clay Cleanse diet, which involves the consumption of bentonite clay. Bentonite is weathered rock that is mined from well below the soil. It has no organics and a relatively consistent composition. The theory behind claims of health benefits from eating clay have to do with the charged surfaces most clay minerals have. Clay adsorbs elements. Adsorb means to attract elements onto the surface of the mineral. In the natural environment, clays will expand or contract depending on what elements are adsorbed onto their surface. The perceived health benefits are that clays will adsorb bad ions. The problem is that clay minerals don't discriminate between good and bad elements. That's why consuming clay can result in deficiencies in important minerals and negatively affect your health. So should you do it? It isn't recommended. The issues are obvious. Soil, like dust, often contains toxins and germs. You really don't want to do that. Depending on the texture of the soil material you're eating, you could end up with blockages in the intestines or damaged organs. You could puncture your stomach lining. You could end up with vitamin and mineral deficiencies. Also, like Gabriel Garcia Marquez's Rebecca, you can hurt your teeth. So much for all that dental work you paid for. I would certainly speak with a physician before embarking on a diet of earth materials. There is very little scientific documentation of benefits. If you like clay, how about a good clay mask treatment? There are both bentonite and kaolinite mask treatments. Regardless of whatever benefits clay might have, you get to relax, look weird, and most importantly, you get to play with mud, all in the guise of good health. Medical geology is a fascinating subject. From a geological, historical, or medical perspective, you can learn a lot and expand your perspectives on your own health and well-being. Always be sure that the information you are reading is from a refereed scientific study, and use geology to help take care of yourself.